It's story time, folks, and I've got a good one for you. It's a twist of the classic tale Cinderella, and well, it's educational. Let's begin. Once upon a time, there was a girl named Cinderella.
Cinderella, you better mop the inside of the nuclear membrane well. Then you can sweep the cytoplasm. You're not going to Princess Ball tonight. You have too much work.
Yes, stepmom. Cinderella wishes that she could go to Prince Ribozome's annual ball, but her stepmom always stops her from going. Little does Cinderella know, but this year, things will be different. Cinderella was cleaning when a voice came out of nowhere.
You are going to the ball tonight.
What?
You are special,
Oh, okay.
but you need to learn how to replicate before you can go.
All right, I'll do whatever it takes to go to that ball.
Now, since this is a child's book, and children do not understand genetics, I need to explain to you what replication is. While Cinderella was being replicated, her double helix was unwound. Each strand acted as a template for the next strand. The bases matched up to synthesize new partner strands.
Now, to do this, the helicase unwinds by separating the base pairs. Next, the DNA polymerase binded to one strand of DNA, forming the leading strand, then the other to form a lagging strand. The DNA polymerase matched up the nucleotides. Then the ligase brought together the fragments, and the protein that regulates winding and unwinding of the helix cut and binded Cinderella's new helixes. The RNA primase then catalyzed the synthesis of RNA primers. All of this works from the 5 to 3 end. Several enzymes and proteins are involved in the process of replication.
And our story continues. Now one of you can go to the ball, and the other can stay here and finish cleaning.
Thank you, random voice?
But there is a catch. You see that weird ball around your feet? That is a transcription factor, and you have to be home before it reaches your head.
When will that happen?
Midnight.
Thanks!
Again, you're probably wondering what happens when the transcription factor is moving along the DNA. Well, I now have to explain transcription to you.
Before the transcription factor starts, the RNA polymerase binds to the DNA, and the promoter sequences tell the RNA polymerase where to start. Then the transcription factors bind as well. The transcription factors start to unwind the DNA and allow the RNA polymerase to copy one single strand of DNA into RNA. The strand used as a template for the RNA is called an antisense strand. The strand that is not transcribed is called the sense strand. After the transcription factors do their work, the RNA strand detaches from the DNA, and the transcription factors in RNA polymerase break off as well. While the RNA polymerase is reading the DNA, instead of using the nucleotide thymine, it uses uracil for the mRNA strand. Then, the mRNA strand needs energy to be able to go out of the nucleus into its ribosome.
All right, now back to our story.
I will find you. This DNA could only belong to you.
The process isn't done yet, Cinderella. Your new RNA self needs to be translated.
Translated into what?
A protein. And to do this, you must run away to the kingdom of ribosomes. There, you must find your true ribosome to translate you. This is my favorite part, the translation.
Translation happens inside a ribosome. A ribosome is where the RNA strand is translated into amino acids. The tRNA, which is essentially the truck for amino acids, wants to bond with its codon match on the mRNA. Hydrogen bonds hold together the mRNA and the tRNA. The mRNA strand is read according to its genetic code, which relates the DNA sequence to amino acid sequence in the protein. 3 bases make a codon, and one codon specifies a particular amino acid. The strand of amino acids is then folded carefully into a protein. The shape of the protein is important for identifying the protein, and so the insulin can attach to the protein. You look familiar. Here, try this. Are you my true ribosomes? Apparently. Will you be translated by me? Absolutely. And they both lived happily ever after.
What a great story. Well, I'll see you next week for another story time.